Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over how to carry out modeling with exponential functions. We're going to be looking at real-life scenarios that can be modeled using exponential growth and decay. All right, so let's take a look at the situation. It reads the equation v of t equals 12,000 times 0.75 to the t represents the value of a motorcycle t years after it was purchased. Question: which statement is true? So we have different questions here that we are to determine which one is true. Okay, so before we get started with the examination of each question to determine which is true, let's take a look at the formula that's going to guide our problem solving process. All right, so we have, for exponential models, we have exponential growth or decay. So which applies to this particular scenario? Is this an exponential growth or decay situation? Now the question is, if you buy, let's say you buy a motorcycle for a certain amount of money, let's say 12,000, what is going to happen to the motorcycle in, let's say, 10 years time? Under normal condition, it will wear out, right? The tires will wear out, the engines will wear out, the seats will wear out. The value will be much less than initial, right? So in a situation like that, when you invest in things like motorcycles or cars, the value depreciates, okay? So when the value goes down is exponential decay. So we're going to be looking at the exponential decay model for this particular case, all right? All right, so the exponential decay model is given by y of t equals a times the quantity 1 minus r to the t. If we had the exponential growth model, this minus will be a plus. Okay? All right, so what do the different parts represent? T is the time. Okay, so t is the time period that elapses. A is the initial amount or value. R is the decay rate. Now, something to pay close attention to, when you're using the formula, the decay rate is in decimal form. So you have to convert it from percentage to decimal form. Okay? So R is the decay rate in decimal form. And then Y of t is the final amount. Okay? All right, so let's take a look at what we're dealing with here. Using this formula, we can determine what the correct answer is. Okay, so the original formula that we just wrote is y of t equals a times the quantity 1 minus r to the t. And let's adapt it to this situation with this motorcycle's value. All right, so v of t is equal to 12,000 times 0.175 to the t. All right, so the first question says the motorcycle costs 9,000 when purchased. So when you purchase the motorcycle, that's basically referring to the initial cost. So this is saying that the initial cost, based on this breakdown we have here, A is 9,000. Is that the case here? Well, let's determine what the initial cost is. So the initial cost is the coefficient that has been multiplied by the exponential term. All right, so this 12,000 right here is your A. That's your initial cost value. So for this particular problem, the initial cost, A, is the initial cost A equals to $12,000. Is that what statement 1 is saying? Statement 1 says initial cost, or the cost of the motorcycle when purchased was 9,000. This statement is false. Okay, this is false. All right. Let's look at the next statement. Statement 2 says the motorcycle cost 12,000 when purchased. So what this is saying is that the initial cost is the initial cost A equals 12,000. Well, what does the equation tell us? A is 12,000. The initial cost is 12,000. This statement is absolutely true. Okay? So the answer to this question is option number 2. Now let's go into 3 and 4 just to help us develop a deeper understanding of the different components of this formula and how to write it in the correct format. Statement 3 says the motorcycle's value is decreasing at a rate of 75% each year. Okay? So the decay rate can be written in decimal and percentage format. So this one is referring to the percentage format since we have the percent symbol attached to the value. So what is the decay rate in this particular scenario that we're dealing with? Well, let's figure it out. The piece that's being raised to the t power, that is what is equivalent to 1 minus r. Alright, so this 1 minus r piece right here is equivalent to 0.75. So we're going to set up an algebraic equation. 1 minus r is equal to 0.75. Now, solving for r in this equation will help us determine what the decay rate is in decimal form, and then we'll convert it to its corresponding percentage format. All right, so let's solve it for r. To solve this for r, we are going to go ahead and subtract. Let's do this. We can add r to both sides. Add r to both sides, and then you can subtract 0.75 from both sides. We're doing 2 steps simultaneously. Let's see, we'll do that. We'll have, so let's go ahead and do that. 1 minus 0.75 is 0.25. 0.25, the r's cancel out. 0.75 minus 0.75 gone is equal to r. Okay, so r, our decay rate, is 0.25 in decimal form. Okay, if we want to convert it to percent format, we're simply going to multiply it by 100. That's how you convert decimals to percentage. You multiply by 100. So 0.25 times 100 is going to give us 25. So this tells us that the decay rate in percentage format is 25%. How is that possible? When you multiply 0.25 by 100, since you have 2 zeros, you are going to move the decimal point 2 places to the right, 1, 2. Okay, so 0.25%, sorry, 0.25 is equal to 25%. All right, so in this particular situation that we're dealing with right here, the decay rate, or the value, decreases at 25%. Okay, so it decreases at 25%. All right, so we got this as a consequence of multiplying 0.25 by 100. Okay, so back to question 3. It says the motorcycle's value is decreasing at 75%. That's false. All right, why is it false? Because the actual rate at which it decreases at is 25%. It decreases at 25%. False. Option 4, the motorcycle's value is decreasing at a rate of 0.25%. Is that correct? This is also false. The decrease rate in decimal form is 0.25, but in percentage format, you multiply 0.25 by 100 and get 25%. Okay, so it's false because of the reason in option 3 is false because it decreases at not 0.25, but it decreases at 25%. So option 4 is wrong. The only correct statement here is option 2, which is that the initial value of the motorcycle was 12,000, the value of A. Thanks so much for taking the time to watch this presentation. Don't forget to help support our channel. If you have any questions, specify it in the comment section below. We'll be more than glad to support you. Tons of resources can be found on Mathgotserved.com or the links in the description below. Thanks again for watching, and we'll see you in the next video. Goodbye.